We're going to sort of explore how AI agents could break down and how to sort of like spot them and how do we sort of build um, um, to stop that. I think so. That's the main focus. Um, so the focus would be we're going to try and look at four failure boundaries. Like these are like possible, very common ways that AI agents can fail, but these are not the only ways. These are relatively common patterns that I've seen when I've been building AI agents for clients, etc. And then let's sort of go through a sample agent to see how that breaks and how we can sort of fix that live. So yeah, it's relatively easy to build break agents. So fixing them is relatively hard. So we'll sort of go through one agent to have a sort of sample ready. So we'll go through that. And I'll also sort of go through the thought process on like when not to use agents. Like you don't always have to use agents. So depending on the problem type, we sort of discuss when to use an agent and when not to use an agent. And then some design principles around building AI agents on how we can sort of build agents in a much more robust way so that the production failures would be less. Or even if it fails, you would know that it has failed. So that's the main focus. And as you go, feel free to add your questions in the chat. And if they're relevant enough for that specific moment in time, I'll pick them up. Otherwise, I'll discuss them at the end. So don't worry, we'll have time for question and answers as well. So yeah, let's get started. So I think like if you build agents in the past, you see that I mean, not just AI agents, but even with like general software systems, you will get it working with demos and with vibe coding and things like that. You could build things much faster. So you'll get like working product really fast, but it will be locally or it will be running locally or it will be working on this happy path, like the non set of path that you build that for. But if you put that out in the wild, especially with sort of actual users, then you'll see the all sorts of issues like edge cases popping up and sort of users not using the system as it's supposed to be using, and then you'll see a lot of integration issues because like the MCP connections and all sorts of tool connections to your agent may or may not work. So that those are some of the common issues, and obviously the scale and cost of that because like agents tend to be sometimes quite costly, especially if they're not working properly. So all of these things could creep up in production. So how do we sort of guard against this? So that's the sort of the main focus that we're going to like try and sort of discuss today. So looking at like the patterns of agents failing, I've sort of like summarized them into these four sort of categories. But these are not the only ways that they may fail, but 80% of the system failures would probably fall under one of these. So I think the first one is like planning failures. So the agent is unable to do what it's supposed to do. So you'll see infinite loops, with trying to like call random tools, and also like doing contradictory actions. So this is one of the first sort of common issues that you start seeing. And then another common one is like memory failures, which is I think before, like if you use like the OpenAI endpoint, you'll probably see this. If you don't sort of like add a memory mechanism to it, it will not necessarily remember the conversation history. So if ChatGPT has the ability to like if you have a single chat history, it will sort of maintain that even across multiple chats, it can sort of save memory, and it would have the context that is needed to have a more contextualized conversation with you. And so the most obvious sort of symptom is that you might have a conversation with the agent or the tool, and like after a few steps down the line, it might start forgetting what you spoke at the top of the conversation. So these are some of the sort of symptoms to show that the memory system is not working properly of that agent, and this is a very common issue. You'll see this a lot with especially coding tools like Cursor when he was first starting. it had this issue that the context, the longer the context window is, it will start losing sort of the efficiency, efficacy of that. So this is one example. Then you have the tool use failures. Like so agents uh, tend to connect to multiple tools, and for example, you could sort of call an API. You can check your calendars. You can sort of check one of your Notion pages. You can do multiple things from an agent. But this tool calling that agent may have may fail because of that. And then fourth one, execution boundary failures. So this is predominantly around like it is not working as it's supposed to, but we're not able to sort of detect them. For example, if it asks it to like, especially if you look at ChatGPT early on, like it had this issue. So at that point, ChatGPT is just like an AI tool, not necessarily an agent. But if you look at the examples, like if you ask it to do math questions, if it asks it to calculate the number of hours in Strawberry, things like that, very common things, but it confidently answers, but it doesn't know, or even like the user doesn't know that it failed. So those are like the much more critical bugs that like know the user nor the system knows that it has failed. So this is that category which is like very hard to sort of find, like when the execution fails, but we don't know the why it failed or how it failed. And we'll go into like individual ones right now. Hope that sort of example is clear. So the planning failures. So what it looks like. So like so the agent enters like reasoning loop. So just to give a quick introduction, if you haven't heard about AI agents, like I want to like try and do a quick introduction to AI agents first, I think. So AI agent is sort of a system or a tool that has a large language model connected for the reasoning capabilities, and it has set of tools like certain actions it can do, and it may have a memory module, and that agent is able to sort of do certain things if you ask it to do, and it can reason about it and do certain things with its ability to its set of tools, and then use those the results, the information that you gather from tools, and then sort of try and execute what the user asks you to do. So it is the like a simple definition. And if you look at this, agents has this thing called reasoning loop. So it tend to sort of figure out what sort of things it needs to do to get the the goal met of the user. But sometimes if the goal is not met, it keeps on going on this condition. So if you are, for example, if a user asks, find me the best hotel in Paris, agent searches for sort hotels, compare prices, then rechecks the same hotels and continues indefinitely. So because there's no sort of a boundary condition in this, we are not asking to check X number of hotels. We've just given like a very broad query. So if your agent hasn't sort of put in place the right kind of checks and balances, it will start going on this loop. So why it happens? No structured decision framework, unbound search space. There's no stop condition. Like it doesn't say like, okay, after X number of iterations, stop the agent. And also this, if you send directly this query to the agent, it may or may not understand the actual sort of constraint and the objective of the user. So you need to probably handle these at different stages of the agent. So the best issue is that you're sort of relying on like prompts like be thorough. So you're not like explicitly defining constraints within the prompt, but also outside the system that the agent has connected to. So you need to like put the right kind of guardrails and checks and balances in place for it to work. So this is planning failures. And then you have tool use failures. And so it is relatively simple, where you try to like uh, call one tool, let's say an API. The agent calls one API, but it sends either wrong payload, or it may sort of call the wrong endpoint. So there could be multiple things that could go wrong. Um, but let's say in this example, so it's rather than so if you type in ask for the um, weather for Tokyo. And if you type like say TOKIO, and if you send that to the endpoint, and the endpoint might not return that information, so it will be a API error. You get 404, that city not found. So that the agent sort of doesn't know how to sort of handle that. So there was no check from before that information is sent, and there's no um, proper contract between the agent and the tool. So like understanding what are the available ways that you can sort of connect with the tool, and there needs to be checks before we send that information. There's no parameter validation. The error is propagated back to the agent. And there's no sort of response verification. So you need to have these like generic, these are like software engineering principles. You need to bring them into this conversation, especially when you're building these robust agents. So the design problem is like the validation layer between intent and execution. There's no validation layer between the intent and the execution. So that's the reason for these tool use failures. So it's a very broad topic, but we'll see in the examples how this could sort of go like really wrong. And then there's memory failures. I think I mentioned this before, like when you have a longer discussion, or even if it doesn't have memory at all, it start losing context. We used to check the weather in Tokyo, gets weather minus 22 sunny. User, what about currency? Then gets Japan's information. So should I bring an umbrella? Then it's asked, okay, which city are you asking about? So it start losing this context at the beginning, because it may not have sort of stored the previous conversation. So that happens because like we are relying on the could be relying on LLM context rather than like some kind of memory. So we don't do any state management, and also sometimes if it there's a token limitation, like it may truncate the prompt that you're sending, and it might sort of lose certain information, and also context window overflow. Certain models have certain context window lengths. Because of that, it starts sort of dropping certain things off. So so the design issue here is that instead of treating conversation history as persistent storage, it is not the case. You have to be very thoughtful on how you design memory around AI agents. This is really interesting topic, something I'm super passionate about. So yeah, I think like memory is a really dynamic. Quite a lot of startups around this space as well, so it's quite cool. The AI agents memory space. Um, and the last one, which is like you wouldn't even know that when it fails. So agent claims an action completed that never actually happened. For example, I ask it to sort of convert do a currency conversion. It just hallucinates and doesn't do the work for us. So why it happens? I think could be multiple reasons. I think one of the biggest reason is like there's no sort of confirmation mechanism. So we don't have sort of checks and balances to see the output that we got is like actually correct. So because like the LLMs in general are built to sound very plausible, like interact like humans, like these answers tend to be very convincing, but in principle it may not be, because especially whether we don't see like the confidence level of that answer when you sort of interact with something like ChatGPT. So because of that, it's really important, especially when you're building tools. When using those API, you have to sort of define these checks and balances, especially if you're working in a very critical environment where financial decisions are involved. If humans are involved, like the healthcare sector, it's really important you do these kind of checks and balances across, especially like having the right kind of eval suits to make sure that the agent, even if you do like a smaller change, if something changes with the tool set, you know really well the health of your agent, so that if something goes wrong, you understand that something is wrong, you need to fix that. So the issue is like no ground truth validation for agent outputs. So you need to have like sort of a golden test sets to make sure that the agent performs in like, especially in edge cases, it can perform really well. And why it's most dangerous, I think the reason is that So these things can get compound in production, and because it sits outside, the impact of this may not be even traceable for you unless you see like a major issue happening. So this happened in a lot of like very early on. There was a situation where Canadian airline sort of had a chatbot, and it sort of gave some sort of wrong information, and the customer sued, and there's millions of dollars worth of like lawsuit that had to settle by that Canadian airline. So because their agent failed and there was no checks and balances, this was like early days of sort of chat GPT based like chat interfaces. So yeah, this is like a really another hot topic that and a hot problem. A lot of people like sort of pay a lot of attention to like building the right kind of eval sets, etc. Um, now we're gonna try and like go through an agent and see like how we can sort of build it up from scratch and see if we can sort of get it working. Happy to take minute or so if there are any questions while I'm going there. Feel free to ask anything. Happy to answer them. Uh, checking. Um, so just checking if there are any questions. Nothing at the moment, but yeah, if there are any questions, feel free to have them in the chat. So um, I'm using this tool called N8N. This is like a very popular tool that helps you build low code, no code workflows, and AI agents are one of these tools that we can build with N8N. So this is an open source tool, and also there's a cloud hosted version of this. So we're going to use this to sort of work with an example and see how we can sort of build that. So this is like the AI agent that we are trying to sort of interact with. Um, and you, as I mentioned earlier, an AI agent would have three main components. You have the chat model, and you have the memory module, and then the tools. Like you can have like not any number of tools, but a lot of tools that helps gives the agent ability to do read information, do certain actions, etc. And this agent can also connect to other agents, other tasks, etc. So right now this agent doesn't have any connections. You can see a lot of informations are there, but we can try and see connect like a chat module. So this chat module, like when you create some sort of workflow in N8N, you need to have a trigger. So it could be this workflow can get triggered by a webhook, and it can get triggered by some sort of action happen on a specific database, or you can sort of have a chat conversation. So if you have chat with it, it will start responding. So this chat interface will, if you click on it, you can interact here. So this agent doesn't have any sort of tools connected. If you say hi, say, okay, a chat mode subnode must be connected and enable. So it does an error, right? So when you go to this agent, it's asking, okay, there's no LLM that is connected to this. So that's an obvious error. So you can try and connect this. I'm going to say, again, hi. As you can see, it sort of went through that and sort of answered that question. So we have set a sort of a template in place to answer it like this. I'm going to ask, let's say, what is the capital of United Kingdom? Then, where is it located? The map. So ask the question. So as you can see, open chat. So if you ask this conversation on ChatGPT, if you ask one question, United Kingdom, like what's the capital of it, and then you go to London back, and I'm asking to where is it located on the map. So it's telling me I don't see an image or a map attached to your message. Could you please upload the map? So it doesn't have any sense that I've had a discussion about London before. So it's not within the context. So the issue is like it's not storing our previous conversations in this. So what I'm going to try and do is like connect a memory module. So the memory module will store our previous conversation and maintain its context. So if you connect that, um, there are a lot of memory modules you can connect to. I'm going to use a simple memory module. If you click on that, you can sort of maintain the context window length here. So that means it will store up to 5 interactions that you had with this tool, and you can sort of use that within the conversation. I'm going to ask again. So it tried to sort of generate image as well. So London is located, southern is part of England. So it sort of now sort of has that context because it's storing that information. So if you look at this interaction, so this shows very clearly the steps that it took to come to this position. So you have so it first checks if there's something some information in the simple memory, which is a memory, and you pull that information and you populate that information before you call the LLM. So that LLM has the previous conversation. So you have the previous conversation and the answer and the new question. So it's sort of an extension that so it has that right kind of context, and you get the reply back, and also it will update this memory again when you see where it's located on the map. Um, so you have that entire sort of you start sort of populating the context, and after like 5 interactions, it will sort of removing the older sort of conversations. So that's how it would work. So now I want to say I want to save this information on my Notion page. Let's say ask it to save this information on Notion page. Um, so it says, oh great, here's a neat summary if you can copy paste directly into Notion page. But it's a manual thing. I have to like copy paste this. I don't like that. So I want my agent to be ability to have sort of connected to the agent. So the issue is that even though there's a node here, it is not connected. So I'm gonna like try and connect this. And if I open this yeah, this is actually searching for information. Um, you see. Since we're creating yeah, to create page on Notion called London. Let's see if we can do that. So it sort of triggered that it got executed. Hopefully let's see uh, if something happened. Not 100% sure. um, Maybe it didn't work. See what happened. Okay, so the title instead of okay, I'll try again. So yeah, so it picked up from the agent and create something called London. And so right now I don't have to manually create that. I can sort of save information, etc. So now I want to see, okay, um, can you let me know if there are any pages called London? So it says I don't have access to search all these pages on Notion workspace. So I thought, okay, I've connected Notion. Why it's not working right now? So the issue is that this node only can write or create pages, write to pages or create pages. So I haven't connected this page that can sort of do search. So I need to connect that. And if I try it again, I'm gonna ask the same question. Yeah, I mean, but it managed to search that, but it couldn't find it. Could be not looking at the okay thing. So it pulled a lot of information from here. Um, thing. Try again. Sometimes just to work like that. Yeah, there's a page called London Ocean page. So I let the agent sort of figure out initially I had like a hard coded value here. So I had set it to be automatically picked up by the model. So I asked, can you let me know if there's any page called London? And it sort of filtered out and got the search term from here, and then did the search based on that and got these results with the URL for that page. So you got that information back. So the idea was that so even though we had sort of Notion node connected, it didn't have the right kind of configuration. So we had to connect that, and then you need to create like another sort of a tool configuration that it can sort of try and sort of read that information back. So it's important that the agent has the right kind of tools and also the right kind of definitions set in place to do this. I mean, this is a very simple example, but like this can sort of expand across in the production as well. Um, so another thing I'll quickly show is that if you need to chat with this outside, like if you need to share this with someone, you can get this public URL. Um, yeah, so this is that. So hi, it's on my um, right. Yeah, I think it didn't pick it up. Funnily enough, but like this interaction, if you go here, these interactions, you can see all these interactions are stored here. You can see like what are the questions you asked and what sort of information was passed through. This entire interaction is stored. So this is quite important. Like if you have this agent running, you could sort of see the interactions that the users had, the time it took, the tokens that were spent. So you have like a really good feel for how the agent performs. So I think it's really important that you have this like observability information in place. So yeah, so I'll go back to see like how we can now think about how to build like AI agents in a much smarter way. Um, so I think the first thing is like figuring out when not to use agents. I think like if you look at it, agents are fun to build, but at the same time, they're not always the best use case, a best application for a problem. So if the user's intent is ambiguous, like for example, like a sort of a chat sort of conversation, or maybe you need to sort of reason and figure out what's the best way to sort of go about, and there's no like correct pathway. And it's very dynamic, the problem set, and you may get unpredictable input variety. So those are some of the scenarios where you need to think about building an agent. But if the the solution for that problem is a clear business sort of workflow, and you need reliability or flexibility, and also if the costs are super important, it's always best to sort of have like a workflow. It's like a if else kind of a logic. You can build it on n8n as well, or Python script, things like that. So that if you know well enough what's your sort of a workflow that you're going to execute, you might be able to sort of code it up or build a workflow. And if you can do that, definitely pick that over an agent. So agents are really good if there are uncertain components, if there's like probabilistic nature to it. Otherwise, it's always best to code and build a workflow. I think that's the first sort of thing you need to like remember with working with agents. And then you have the sort of structure of it. And you can sort of be super smart about sort of prompts. I mean, there's you can go to a certain distance, but beyond writing very structured prompts, you can also have right kind of like a system design, like you just outside the agent, like you make sure that the order of execution of a specific task, you define it in a way that okay, you first if the check the order status and then only do the process refund request, and you can sort of have refund amounts at capped, so you have like these hard checks and the endpoints. Sometimes you need to have a human approval, and also like do validate the order status if it is delivered. So things like that. So you can like do these checks outside the agent and make sure that things works smoothly. So these constraint and sort of definition should wrap around the agent so that the system sort of works smoothly. So that's one of the things I would highlight, like the structure of the system is much more important than sort of smarter prompts, because prompts can be sort of overridden. You can sort of like jailbreak agents. Like if you have right kind of structure, you can sort of build really reliable system. Then second point is like um, first understand that agents are going to fail, especially early on. So it's very important that you make these failures observable. So that means like you need to log certain kind of information, and you need alerts on certain kind of information. So if you look at like this is not a hard and fast rule, but these are like relatively um, loosely defined sort of categorization. It may depend on your use case, but if you look at on the left hand side, like every tool call with parameters, the reasoning chains, state transitions that as we saw in N8N, token usage per request, error responses. So those kind of things we can log. So on alerts, If the token usage spikes, like if it's like going through a loop, you need to alert that like these are like super critical ones. And then retime patterns, like if there are like certain tools are failing, that's gonna have like longer impact. So it's very important that you pick them up in alerts and hallucination keywords. Like especially if it's failing um like without knowing, so you need to have like pick and choose like when this happens you need to get alerts, and also cost obviously, so you need to make sure that your costs are under control. So if certain cost thresholds go above, you need to have these in place within the agent. So there are ways to do this, and I'll sort of like we can discuss them during the Q&A. um so the third one, I would say sort of design your failure mode. So I think like it's very important, if you can, rather than failing silently, it's better to fail loud, because yeah, it's business critical at the end of the day, right? So hierarchy of failures, like best to worst. So reject request with clear explanation. It's a failure, but it's fine. Then ask for clarification or get human help. So that's the second tier. Third one is partial completion with warning. So yeah, so you give like some level of caution, but you give some information back. But the worst is like silent failure, and we don't know like when it fails. So that's like super, super bad. Then you could have like practical guardrails around this, like so you could have like circuit breakers, like if it goes through a reasoning loop more than like 5 iterations, you break it. You could have like budget per session, like $0.5 limit, etc. Human in the loop for especially actions which especially may have like a real world outcome. So you can have human in the loop. We could also have timeouts, things like that. So the bottom line is sometimes it's okay for an agent to break rather than doing irreversible damage out in the wild. So when you have this kind of design in build, you could have a system that agent that can run for a very long period of time. Even if it fails, it doesn't have like a lot of damage done. So that's the third principle. Um, so the key takeaways from our discussion. So the agent reliability isn't about writing very smart prompts, not like having like really impressive models or more training data like with like future learning, etc. It's not the case. It's all about like understanding failure boundaries, like what sort of ways the agent can fail, and sort of designing around that. So like right, having the right kind of observability integrating the system, having the controllable failure modes. Like if it fails, like what's the backup option? Are you gonna escalate that to a real user? Are you gonna like log that in? How do you trigger an alert? So you can sort of define these in. Um, and then knowing when not to use agents. Like as I said earlier, there are sort of situations you don't have to use agents just because they are fun to build. That doesn't always mean you need to build it. And then um, if you think about it, um, like the best engineers or best agent developers are like people who are like system thinkers rather than prompt engineers. Like so, if you have a good system thinking knowledge, or an engineer, or even like a really good product person who thinks in systems, it's really easy to build really good systems. Um, so that's the way I would sort of prioritize this and thinking about this. So yeah, those are some of the key takeaways from the session, and I want to like leave some time for questions for us to have a discussion as well. Yeah, I think, Tanuj, I think we got a question. Could you please run through the design principle one more time? Okay, let's see. Yeah, I think yeah. So in this example, like so what I'm trying to say is um generally you try rather than trying to enforce everything through the prompt, um, you build systems around for your agent outside. So for example, if I say if I go back to the net, so this agent could trigger some action here. So if I click here, sorry, go to editor, go here, I'm gonna say send an email. So I'm not gonna connect that, but I'm gonna just put it here. So this would send an email to someone if something happens. But the issue is like if when that sort of the logic to send an email, we say in the agent, we say, um, uh, wait, so so the agent like knows that it can send emails, and without any checks, it will sort of send it out. But you can sort of instead of directly sending it, you put a guardrail. Uh, so yeah. So you can put certain values here to check for like to remove certain words, etc. But before it sort of sends the email, it sort of checks this. So right now we are not defining things within this agent's prompt, but we are making sure that output that goes out with this agent will get checked before that email is sent. So that's what I mean by sort of building the system in a way without not just prioritizing the agent so the prompt. Hope that answers the question, Tanush.
Yeah, it does, Eki. Thank you.
Okay, cool. I think there's another question. Can you share resources on best practices and frameworks on how to think in system? So I think, yeah, I think there are some books around this for sure. I think if you're coming from a engineering sort of a background, it's an extension of what you learn in engineering, right? So thinking from how do you build something in a more reliable manner, and how do you know if something fails, and how do you have the right kind of observability? So those are some of the sort of engineering principles that you sort of can bring in for building AI agents. And but yeah, I'll sort of share some stuff as well. Like yeah, I'll try and find something that could be used to sort of learn how to think in systems. But yeah, I mean, really good question.
That's kind of
Yeah,
like what we could
yeah,
basically.
yeah, yeah, 100%. So I think like the immediate sort of thought process is like sort of following some folks. I mean, like LinkedIn, Twitter, and some newsletters around like AI work done by a lot of engineers. So I do have engineering background, so I do post a lot of stuff. But like more than me, I think there are like folks like Andrew Yang, one of the famous like professors at Stanford. So he's a really good teacher, and he's from deeplearning.ai. Their courses are a bit outdated right now, but more than that, they have a really good newsletter. What is called? So let me share my screen quickly. So they have a newsletter. So this one, deeplearning.ai, I put it in the chat. So this is something I follow. And they don't send too much stuff like every once a month. They send some stuff, but they are quite like up to date. So they're like he was talking about AI agents like two years ago. So that's like in general. So I think so he's a bit far ahead of the game. So he's good. Obviously, Andre uh, Karpathy is another sort of a leader. So he has like a really good sort of a blog. Not sure which is the right blog. He tweets a lot as well. Let's see what's the latest. Yeah, so this blog is quite good. So he talks about so I wouldn't say necessarily system thinking, but he's sort of like thinking about like the latest context, latest sort of information. So you can sort of understand, sort of relate these things like if you wanted to navigate on how to build systems. And he's head of engineering AI at Tesla before. So it's like, yeah, really awesome guy. Like a lot of engineers respect him. So the things that he normally talks about, I mean, obviously don't take everything he says at face value, but he's someone who can relatively you can trust. So check their background, I would say, first. Like, do they have like some credibility on what they're talking about, rather than necessarily flashy videos and flashy content? I think, but yeah, I think those are the two immediate sort of folks I would recommend to follow. But I'm sure I can find a few more, and then I can sort of share them. Do reach out to me on LinkedIn, if possible, so I can send them over. Yeah, hope that was helpful. Um, I'll put this and this blog as well. Any other questions, guys? Cool. Um, I'll give a few more seconds. Um, so I think is the question is around sort of looking at comparing OpenAI's agent in A10 and what's the other one you mentioned? LangChain, is it? Yeah.
LangChain. Yep.
Yeah. So I think, um, yeah, I think how I think about it is like OpenAI stuff, I would sort of play around with it, like if I need to like brainstorm something very quickly. But if I need to build like a prototype or like get to like maybe 10 to 100 users, like something I'm building, I go for something like NA10 and get it working and test out my idea. Like if I need to show something to public. But if I'm thinking about like long term, like I need like something that I need to um sort of grow to like a large audience that like so like multiple like thousands of concurrent users, I'll probably use it, build it from scratch. Obviously some LangChain is one option, but there are like multiple options. Like I would use something like Google's agent development kit, which is I use a lot, which helps you define the agents in a much more abstract way, and you start building from scratch. There are a few other players like Crew AI, so provide a lot of libraries, but I think yeah, so there are a few options, but I would probably go for a more Python based sort of a solution, and sort of building it from scratch. I'm 100% sure like AWS should also have something. I know like they have the Bedrock and they've sort of introduced the agent architecture recently. Let me see. Yeah, Bedrock has AI agents. I've used them a bit, but not a lot of in like, so I'll share that as well. Um, yeah, so I'll check this as well. And there's agent SDK Google. So these are like my go-to sort of tools right now because these are much more built by Google and Amazon. So they are sort of backing is strong and they think about like these scaling requirements when you need to like scale these agents to thousands of hundreds of thousands of users. So that's my sort of like go-to sort of tool set, I would say. Hope that was
Great.
helpful.
Appreciate it.
Yeah, cool. Amazing. Yeah, I think Tanuj, another question. Do you have any enterprise grade examples of how agent have been tested? So it's a question about more like um I put my LinkedIn as well, by the way.
So deployed N8N on my local server. So
Nice, nice. Yeah.
who have in past used like a business process automation, or there are some other.
Yeah.
So my question is that how.
Trying to understand the question, Tanuj. I think is it about like how do you differentiate yourself across? That's what I got at the end. Like, what I didn't understand is like, how do you compete with like large organization if you build agents? Is that the question? Or? Yeah. Oh
So
yeah. Yeah. I mean, it's a really good question. Something I think about all the time. So I think like so if you so I would try to break it down to like few sort of tiers. Like the immediate thought that comes to my mind is um, if I'm building an agent for a very critical domain like a healthcare or a financial sector domain, I wouldn't let it run the entire workflow end to end automatically. I would
Mhm.
definitely have like an human in the loop where
Right.
we sort of like look at like an existing function that somebody does and we automate that. And even if it does like a really good job, better job than the humans, you need a human at the end of the day to sign it off. So because of that, you need like from a legal point of view, you can't sue necessarily an like a agent. You either sue the company or sue a person. So because of that, you need to like have somebody legally from legal reasons, but also from a practical reasons because agents can hallucinate. So you need to have somebody sort of sign it off. So where I would see this, like if we look at like leading AI tools like Cursor, that like a really good example of how you build agents for a specific domain. It's built for coding. So even like if you don't let it like run wild with just pure agents, you it will ask you like before you edit something in the most safe mechanism, safe with safe guardrails. It will ask you like, okay, I have these sessions. Would you accept? Would you keep them? So you have like human feedback in that process. So that's one way of doing it, and also like obviously things regarding privacy, etc., can be managed with some things like NA10 or you like delivering this locally. So that's one sort of constraint that you may have around privacy because you can't necessarily send information to outside services. So I think those are the two immediate thoughts that came to your mind about this. But yeah, happy to have a long discussion on this. I think it's a really,
Yeah, and then we can
yeah,
have
yeah,
a
please
long
do, please do.
conversation.
Like, yeah, happy to have a
Thank you.
conversation. Yeah.
Thank you.
Yeah, thanks a lot for that question. I think James has a question. New to agents, where do I start? So the best place is start with probably N8N. I think like yeah, you can get like a free as Tanuj did, you should connect with Tanuj. Now he knows how to run it locally as well. You can download and run it locally without any issues. So N8N, you don't have to pay for it. You can download it and run it. So if you need to deploy it, you need to think about costing, but for testing purposes, you can build agents locally. Um, yeah, guys, please put your LinkedIn as well. Do connect with everyone who's in this call. Like, it's a good opportunity as well. So everybody's building agents, um, and um, and yeah, I think like start with N8N. That's the best place, and experiment with new tools like LangChain, like the agent development kit I shared. Try with OpenAI sort of agents as well, so you can sort of experiment with them. Hope that answers the question, James. What type of software use case are you helping build at UN? Yeah, I think I'm on an NDA that I can't talk about that, but like, yeah, there's a lot of automation work using AI that are working there. So, but yeah, yeah, yeah. Um, so I wouldn't use N8N for memory though. I would still use N8N because even if I connect memory, like if you think about it, like this, like the immediate sort of like the agent I showed. Let me quickly show you guys. So if I try to connect like another memory component, let's say I'm connecting Supabase, which is um, I think Postgres. Like yeah. So so uh it needs to have Supabase. Let me see if I can find it. Yeah, so if I'm connecting like a vector store of some sort, so you probably need that aspect so that that information gets stored here. So if you're connecting that of some way, maybe not this is not the right module, but at the end of the day, you need to sort of connect with your sort of agent with the credential, and you need to connect with your sort of server base side of things. So what you replace here is the Superbase sort of the edge functions, which is like running the specific logic, like the scripts that you can run to get something done. So what you're replacing is the backend logic of so if you looked at like a full stack application, you have the front end, the back end, and the database and authentication, I would say. So the database and authentication would probably should come from Serverbase. And but if you really need, you can replace that backend logic part with innate. And so that's how I think about it. And whether it will replace it or not, I don't know 100% because this has certain limitations around scaling and like the flexibility around it. But it's a really good tool. Like you can do a lot of things. You can like build like really good businesses around it. But sometimes you probably run to certain constraints, and it's not the easiest to transform your N8N based business very easily. If you're in N8N, you can sort of do a lot of tweaks, but if you want to switch to Python, there's no straightforward way I think you can do that. So that's the only thing that I'll be mindful about if it is like a scaling business. But having said that, not every business need Google level scaling, right? Because that's absurd. You need to think about this like massive user count because I think if you have that problem, that's a good problem to have. You can sort of hire people to solve that. So that's my sort of way of thinking around this. Hope that helps. Cool. Amazing. Yeah, I think there are no other questions.